So suppose you want to verify that the integral on the left-hand side, the integral of sine squared of x dx is equal to x divided by 2 minus sine 2x divided by 4. How do we do that? In these cases, we usually say, hey, we have a quantity on the left-hand side, which is integral, and we have a quantity on the right-hand side, which is this expression here. To show that left-hand side and right-hand side are equal to each other, we're going to take the derivative of both sides. So take the derivative of both sides. The derivative dx of the integral of sine squared of x dx. As you remember, intuitively, the derivative and integral, they are opposite operations. So they get canceled out. On the left-hand side, you end up with sine squared of x. But what is your right-hand side? On the right-hand side, if we take the differential or take the derivative of this quantity, it is ddx of x divided by 2 minus sine 2x divided by 4 plus constant of integration. Okay, what do we see here? You have x divided by 2. The derivative of x divided by 2 is a half minus the derivative of sine 2x is 2 cosine 2x divided by 4, and the derivative of c as a constant is just 0. Well, on the left-hand side, I have sine squared of x. On the right-hand side, I have a half minus cosine 2x divided by 2 plus 0. But if I take the common denominator between these two, I get 2, 1 minus cosine 2x. Are these two equal to each other? What is 1? 1 from pre-calculus is sine squared of x plus cosine squared of x. This is my 1. I'm going to copy down negative cosine 2x. But from pre-calculus, remember that cosine 2x can be written as cosine squared minus sine squared. So you have negative, let's open a bracket, cosine squared of x minus sine squared of x. So this is your cosine 2x. You can simplify it and write it this way. And all is divided by 2. So we can just add this here or add this here, right? Or let us just consolidate all of these into one fraction so you can see how it simplifies later. So here you have divided by 2. Now, let's move up a little bit. This is equal to, if you distribute the negative sign into parentheses here, you get sine squared of x plus cosine squared of x minus cosine squared of x plus sine squared of x divided by 2. Okay, cosine squared and negative cosine squared, they get canceled out. What is left? You get 2 sine squared of x divided by 2. 2 and 2, they get canceled out. So you're left with sine squared of x. Sine squared of x on the left is equal to sine squared of x on the right. So we just verified that the integral of sine squared of x dx is x divided by 2 minus sine 2x divided by 4 plus constant of integration. As long as you have integral on one side and you don't remember the formula, sometimes the students use this as a shortcut formula. But on the exam, if somebody asks you, hey, verify that this integral is equal to x divided by 2 minus sine 2x divided by 4, you either have to take this integral or take the derivative of or differential of both sides and show that left-hand side is equal to the right-hand side. So in this question, we want to verify that the integral of x squared sine x dx on the left-hand side is negative x squared cosine x plus 2 integral x cosine x dx. So again, you have something on the left-hand side. You have integral on the left-hand side. And on the right-hand side, you have a combination of an integral and a quantity, right-hand side. What are we going to do? We're going to take the differential of both sides, d dx and d dx. Then we check to see if the terms are equal to each other or not. X squared sine x dx, and here you have negative x squared cosine x plus 2 integral x cosine x dx. The integral and the differential on the right-hand side is a little bit easy to work with because intuitively the differential and the integral, they are opposite operations, so you can cancel these two out. On the left-hand side, you have x squared sine x. On the right-hand side, you have a little bit of more work. Why is that? Because here you have the multiplication of two quantities. You have negative x squared, which is multiplied by cosine x, right? So you have to apply the product rule first, right? Remember that if you have, let me write it here. If you have f times g, and you're taking the derivative, product rule says it is f prime g plus f g prime. So we're going to use this for this portion of calculation. Okay, it's not that difficult to see. It is equal to the derivative of negative x squared is negative 2x times cosine x. And then the derivative of cosine is negative sine. Negative and negative, it becomes positive. So you get plus x squared sine x. And the derivative of the integral on the right-hand side, the differential and the integral, they are opposite operation, it gets canceled out. So you're left with 2x cosine x. Well, it wasn't that bad, am I right? Now we can see that, hey, we have opposite terms. Negative 2x cosine x, 2x cosine x, they're opposite terms. We only left with one term, which is x squared sine x. So you have x squared sine x on the left, x squared sine x on the right. They're equal to each other. So we just showed that left-hand side and right-hand side are equal to each other. We take the differential and we apply the product rule.